Hey gang, today we're looking at factoring polynomials completely. All right, let's see what we've got in store. So steps, we have to look for the greatest monomial factor. If it is greater than 1, you're going to factor that given polynomial into a monomial times a binomial. So you're going to take out a monomial that is a factor of all the terms of the polynomial. Second, you're going to examine that polynomial factor or the given polynomial if it has no common monomial factor, by looking to see if there is a trinomial that can be factored into the product of two binomials, or if there's a binomial that are the difference of two perfect squares and can also be factored into two binomials. Third, you're going to write the given polynomial as a product of all the factors above. Make certain that all factors except the monomial factor are prime polynomials. Last, if it is not possible to factor a problem if it's prime. So sometimes you're going to get something that's not factorable, and that's okay. You just say prime. It cannot be factored. All right, so let's see what we have here. This sounds really, really tricky. I like it. It's like taking apart a puzzle. I think you guys can handle it. All right, so here is our first example. We have by squared minus 4b. Notice right away that both terms have 1b. So that is going to be our common monomial factor that we can take out. So we factor out b, and we're left with y squared minus 4, because b times y squared is by squared, and b times 4 is 4b. So now, if you really pay attention, you look inside the parentheses, y squared minus 4. Y squared is a perfect square, and 4 is also a perfect square. And it's a minus sign, which means we have the difference of two perfect squares. So we can factor that into b times y minus 2 and y plus 2. And if I were to multiply this all back out, I would get this binomial as my answer. So now we've factored that completely. All three of those terms, or all three of those polynomials, are prime and cannot be factored further. Okay, number 2, 12p cubed minus 3p. They both have p's, and 12 and 3 have a factor of 3 in common. So we're going to factor out 3p, which gives me 4p squared minus 1. And again, I have a difference of two perfect squares. So we have 2p minus 1 times 2p plus 1. And again, if I were to multiply all three of those factors together and simplify, I would get my original binomial. All right, so that's factoring completely. Let's take a look at some more examples. Number 3, we have 3a squared minus 20. Well, there isn't an a in both terms, and 3 is not a factor of 20. So this is what I was talking about. This is not factorable. This is what we call prime. Then 4. We have an x in each of those terms, but then 7, 10, and 1 don't have a common factor. So our monomial that we can factor out is x. Then that leaves us with x squared plus 7x plus 10. So now I want to see, well, is there two numbers that are factors of 10 that might add together to get 7? And we know 5 and 2 add up to get 7. So I'm going to use substitution to simplify. So we have x times x squared plus 5x plus 2x plus 10, or x grouping times x plus 5 plus 2 times x plus 5 gives me x times x plus 2 times x plus 5 as my final answer. And again, if I were to multiply that all out, I would get back to x cubed plus 7x squared plus 10x, proving that they are equivalent to each other and now factored completely. All right, let's continue. You're going to try 5 through 8 on your own. All right, back to me for number 9. If 9x squared plus 30x plus 25 represents the area of a square, find the binomial that represents the length of a side of the square. All right, so again, we're talking about a square. Now remember, a square is the same, has all the same sides. So we should get two binomials here that are exactly the same if we have a square. So 9, 30, and 25 do not have any common factors, so we have to use the process of factoring the trinomial by grouping. So we start with 9 times 25, and 9 times 25 is 225. And we want to find the factors of 225 that have a sum of 30. And that would be, if you're savvy, 15 and 15. 15 times 15 is 225. I know that because it's a perfect square. And 15 plus 15 equals 30. And I was also thinking it had to be the same since this is a square. So now I want to group 9x squared plus 15x plus another 15x, replacing the 30, plus 25. Group and group. 9 and 15 have 3x in common, and I'm left with 3x times 3x makes 9x squared. 3x times 5 makes 15x, plus 15 and 25 have 5 in common, no x because only one term has an x, and that gives me 3x plus 5 again. So my common binomial is 3x plus 5, which happens to be the same as what's left over, 3x plus 5 again. So we could say the side length is 3x plus 5. And if we wanted to, we could take this and write it as 3x plus 5 all squared, since it's the same binomial being multiplied by itself. Okay, so you're now on your own with number 10. Remember that volume is length times width times height.